Welcome. So I want to go through a little bit what happens with left hand and right hand limits. Okay. So what we're talking about, so if we have some kind of function, right, and we have the graph of some function, so this is like my y equals f of x. And then we have some kind of value a. Okay. Now I can ask what kind of happens as I approach this from the left hand or the right hand side. So this is my right hand limit. So we write this as, right, this would be the limit as t approaches a from the right hand side. So this is the right hand limit. And what we're actually looking for as an output is we're looking for what happens with, right? So we look up here and we're looking for what happens with, right? This is what happens with y equals f of x, like what value it's approaching. So in this circumstance, it's totally fine because it's a finite value, but it might actually be infinite, okay? And if I'm approaching from this side, so this is a limit as t approaches from the minus side, so this is the left-hand limit. With what we're actually looking at is the value that's approached like that. Okay? So what are some of the different things that could happen? So I could have as I approach a from, so if I want to approach, right, so this is like the right hand side. If I want to approach, maybe it's possible that, okay, so in this particular circumstance, we would have, so this is, oops, this is y equals f of x. And in this circumstance, we would have that the limit as x approaches a from the right-hand side. So, or t, I mean, but here I've got this kind of x, so I'll do it that way. So we have x approaches a from the right-hand side. So I would kind of write it like this, of f of x would equal plus infinity. Okay, because as I approach from this side, I go infinitely far up, okay? And what I say if, and I could do a similar thing over here, so in this picture here, right, this is how I approach it from, you know, I write this as like this, and in this particular circumstance, and I would say, right, so again, I approach plus infinity as I approach from that side. So in this circumstance, I would say the limit is going to equal plus infinity as, right, x goes to a from this side of f of x. Okay, and then what would happen if instead the graph of the function, what if instead y equals f of x went like this? Okay, so if this was my y equals f of x, then, well, as I approach it from this side, the graph sinks down infinitely, so this is going to be minus infinity. So this limit is going to equal minus infinity. So this is the limit of f of x as x approaches a from the right, or we write that by putting a little plus there. Okay. And then similarly, if the graph of my function went down infinitely like this, this is again an infinitely negative limit, so this is going to be, now we'd have that the limit of f of x as x approached from the left-hand side of f of x would be minus infinity, because as I approach from the left-hand side, I go boom, down, and that gives me a minus infinity. Okay, so these are kind of the different circumstances to look at. So then if I have an integral, so for an integral, so we have the integral from, you know, a, so this is kind of like our a, to some value. So this is some value b, okay, of f of x dx, okay, where we have with, we have some kind of circumstance where f of x is undefined at a. Right? And a good example, for example, would be the function where I would have f of x equals 1 over 1 minus a, for example, would be a great example like that. Okay? The way that we do this is going to equal the limit as t approaches a. Okay, well, let's think about this for a minute. Is that if I'm doing an AB, right, I'm looking at a picture where, right, I have an A here. I have a B here. So, and I guess I would like to make this orange here. So this is T goes to A, right? So if I'm approaching, if I want to stay in this interval and approach, I need to approach in this direction. So I want to put a plus of, and then we do the integral from T to B of f of x dx. Right? And then we could also do this approaching from the other side, okay? That we could also look at the integral from, and now we could start at B and approach A. Okay, so now I'm in a situation over here where I have my A is on this side, my B is on this side. So if I want to approach from within the interval, I'm going to be approaching like this, okay? So I'm actually going to be approaching from a minus side. Okay, so this of f of x dx is going to equal the limit, and then we have an integral, and then our b is down here. We replace the a with this t, and we're approaching t from, now we're going from the a minus side of f of x dx. Okay, so, right, so what we end up getting, so these are how we would compute these in these circumstances where you end up having that your function is actually undefined at a, and to kind of see how you compute them, you actually use this right hand and this left hand limit. Okay? So, and so a lot of times I actually find with students, it helps to draw the pictures because it's hard to remember, oh, I have to stay in this interval when I'm approaching A. Okay, and so you want to have a circumstance where in this circumstance, in order to stay in the interval, I have to use the right hand limit. In this circumstance, to stay inside the interval, I have to use the left hand limit. And I think that can be hard to remember if you don't actually draw the pictures. So I highly recommend actually drawing the pictures anytime you're getting a little bit confused. Okay, so I hope that makes some sense, and I will see you in the next lecture.